Okay, I apologize that I'm not there. Before we start today's warm-up, I want to go back to the last day I was there, which was like Monday, when we did this problem, number 3. We found two different equations that could represent the same sine-cosine curve. No one mentioned it, and no one pointed it out that I did something wrong. Cosine, if you have your midline for cosine, it usually instantly does the amplitude, then it's on the midline, then it's down, then it's on the midline, then it's up. So cosine starts up, or if you think about the points, 0, 1 is the value for cosine on the unit circle. The x value right there is 1. So cosine normally goes up first and then down. But mine is going down first and then up. So what are we missing? We need a negative sign. That little, it looks like a dot, but it's supposed to be a negative sign. Make sure you include that. Go back and fix it. I don't like things being incorrect in our notes. Okay, so last night you learned how to graph tangent and cotangent. Basically, we're going to graph tangent, and then we're going to rip it and flip it if it is a cotangent problem. Here are my answer blanks. I will start color coding things, but you can pause it and see which ones you can fill in. Okay, tangent, just like secant and cosecant, does not have an amplitude. This does not exist. We probably won't ask you for it, but just in case, amplitude does not exist. It does have a vertical transformation because there's a 2 in front of it that's stretched vertically. It already says vertical on the answer blank, so I'm good with stretch. It is not negative, so there is no vertical reflection. Period for tangent is pi divided by b. Pi divided by the imaginary 1 is just pi. I don't need to see the divide by 1. Phase shift, it's going to go left pi over 4, and vertical shift, it's going to go down 1. Okay, through the magic of YouTube, I have already started my table for tangent. Remember, for tangent, as we go around the unit circle, and we're going to talk about this more later, we are going to start at negative pi over 2, which just means down here. We're still going to go this direction until we get to positive pi over 2. Because after that, the tangent answers just repeat themselves. So that's one reason why we always stay in that little quadrant 4 and quadrant 1. So at negative pi over 2, that is the point 0, 1. When I do y over x, remember tangent is y over x, that's going to give me 1 over 0, which is undefined. Negative pi over 2 is undefined. As I'm going around, I'm going to get to negative pi over 4 right in the middle of that one. Those x and y's match, but one of them's positive and one of them's negative. Also, it's just downhill, so we know it's negative 1. As I keep going, I'm going to be at 0 radians. That is the point 1, 0. 0 divided by 1, y over x is 0. Keep going, positive pi over 4. I'm here now. That's going to be positive 1. And back up at pi over 2 is also going to be undefined with a d. Good enough. So these will always be the points you start with, and then we're going to transform these ones for tangent. So same rules as always, x over b plus or minus c. So x divided by 1 minus pi over 4, and then ay plus d, 2y minus 1. I'm going to pause it. You go through and do these. I'm going to do that thing where I add an extra column so that all of them have the same denominator. See if you can get these. I'm going to fill my x's all in. When you unpause the video, all my x's will be there. Okay, I lied. 3 of my x's are going to be there. Hopefully those are the first 3 you got. Because they're all over 4, I noticed that they're counting up by 1/4. So next is going to be 0, and after that is going to be positive pi over 4. Now do your y's. Okay, important thing to know that once a number is undefined, you can't do any math to it to change it from being undefined. So my original undefined y values will remain undefined for my new y values. So counting by pi over 4 is kind of a lot in the negative space. So let's make a good table. So my y-axis could be over here because I need some negative x's. And it goes down to negative 3 and up to 1. So maybe I'm probably going to count by 1s on this one. So negative pi over 4, positive pi over 4, and then just count the rest out. Negative 1/4, 2/4, 3/4. It's going to be kind of small, but that's fine. And then positive 1, negative 1, 2, 3. Plot what we have. So there is an asymptote, it's undefined, that is an asymptote at negative 3/4. It is undefined, that is an asymptote at positive pi over 4. It has a point, -2, -3, negative pi over 4, -1, 0, 1. Tangent kind of looks like a cubic. I missed my point, but you get the idea. And it would repeat over here as well, but we graph one period of tangent. Write up those answer blanks that we always have and see how many you can fill in. Okay, tangent, domain, range, asymptotes, even, odd, neither, y-intercept. It has no relative mins or relative max, so we won't ask you for them. If we do, you would say does not exist. So asymptote is always the first place to start. I always choose the one on the left side just because that's what I choose to do. You could choose either one. It's at -3 pi over 4, x equals -3 pi over 4, plus or minus, and there's one every period. Period is pi in this case, so pi n. So domain, all reals, comma, x cannot equal -3 pi over 4 plus or minus pi n. Range, it goes up and down forever, all reals. Even, odd, neither, let's do that y-intercept first. The y-intercept is at 0, 1. You can't fold this and have it land on itself. Tangent can never be even. And then because there's a vertical shift, this one cannot be odd either, so this is neither. Number 2. Copy it all down. Okay, to get us started, we are going to do the tangent graph, but I guess I should do those answer blanks first. Okay, got them all color-coded. Amplitude, tangent, and cotangent do not have an amplitude because they don't have any hills or valleys. Vertical transformation, a half is compressed. It's not negative, so no reflection. Period, pi divided by b, which is an imaginary 1, so just pi. Phase shift right, pi over 4, and vertical shift up 2. Make your tangent table. I'm going to make mine in gray because it's not going to be my final answer. At negative pi over 2 is where tangent starts, and that's undefined. Then it goes to negative pi over 4, that's -1. Then the 0, that's 0. Then the pi over 4, that's +1. Then up to positive pi over 2, which is undefined again. Write your formulas at the top. If I'm going too fast, it's because I know what I'm doing, and it's a video so that you can pause it. So pause the video at any time. On top, x divided by 1, so just x plus pi over 4. 1/2 y plus 2. I'm going to do that thing with the common denominator again. -2/4 plus 1/4 is negative pi over 4. -1/4 plus 1/4 is 0. 0 plus 1/4 is 1/4. Counting by 1/4, so 2/4 and 3/4. Do the y's. Check out my y's, then set up some axes, barely in the negative for x's and not in the negative at all for y's, so maybe right here. It is counting by fourths, so negative pi over 4. 1/4, 2/4, 3/4, 4, 5, 6, 7, 8. We might use those later. 1, 2, 3, 4. You get the idea. I'm doing this in gray because this is tangent and we are trying to graph cotangent ultimately. Negative pi over 4 is undefined. 3 pi's over 4, so my third tick mark is undefined. 0 is 1.5. Pi over 4 is 2. And 3 pi over 4 is 2 pi over 4 is 2.5. See how close these dots are together? That's because it was compressed, right? Tangents, the vertical distance between those dots is usually bigger, but this one was compressed. Okay, to get our cotangent graph, it's a good idea to keep going. That's why I did so many tick marks. So 1 tick mark away from the asymptote was up at 1.5. 1 tick mark from there was at 2. Then that was at 1.5, and then that was an asymptote. So if you space your tick marks out correctly and carefully, you should be able to get 2 cycles of tangent, because now we are going to rip it and flip it. So find the midline, that midpoint of tangent. If it was, that's where our intercepts end up being, our zeros. If it was a 0, if it hits the green line on tangent, it becomes an asymptote for cotangent. This one also becomes an asymptote for cotangent. And then if it was an asymptote, if it was undefined, it becomes a 0 now, so that's a point. And then these other 2 gray points remain points. So our cotangent's going the opposite direction, like this. Answer blanks. Okay, remember we are looking at the red graph. We are only looking at the red graph. Everything else was just to get there. Domain, well, asymptote, sorry. This red asymptote is 1 tick mark in. That is happening at x equals pi over 4, plus or minus the period for this one is pi n. So the domain is everything except for exactly what I said. Range goes up and down forever, all real numbers, no min or max. Even, odd, neither. We talked about how tangent can never be even, and we also talked about how as soon as there's a vertical shift, it can't be odd, so this is neither. You can see where the y-intercept is going to be, because remember I said, I need a color that you'll notice, that these points will be points for the actual cotangent itself, but let's find it just in case. I'm running out of space, so make this work. Plug in 0 for the original equation. I'm going to do tangent of negative pi over 4. Negative pi over 4 is here. The pi over 4s are your positive and negative 1. That line is clearly going downhill. So the tangent of that is clearly going to be negative 1. It's also one of the numbers we're memorizing. And when I flip over negative 1, I still get negative 1 plus 2. So negative a half plus 2, which is 1.5, which is where that number clearly is. So 0, 1.5. Okay, I think that's it. Yep. I hope you guys are doing good. Make sure you take your time on your worksheet and that you're not just copying it from the key, but actually trying it on your own first.